Now let's get away from the word problems and look at some more conceptual questions. So we have solve for n. So we have n choose 2 equals 21. All right, well, I'm going to write this using the formula. So it's going to be n factorial over, well, we're choosing 2, so 2 factorial, and then it's going to be n minus 2 factorial, all equal to 21. So let's simplify the left side as much as we can. I can make it so the numerator is also n minus 2. So if I go n, and then n minus 1, and then n minus 2 factorial, all over, well, this is 2 factorial is just 2, and then we still have n minus 2 factorial, still equal to 21. So I can cancel out the n minus 2 factorial, so we're left with 1 there. And then after that, well, you know what, I'll write this out one more time, just to make it a little more clear. So we're left with that. Now the opposite of dividing by 2 is multiplying by 2. So I'll multiply both sides by 2. And I get n times n minus 1 equals 42. It might be tempting to expand this, do some subtraction, and then you can actually go and factor it out. But there is an easier way. We know that this number and this number, the difference is 1, like it's descending by 1, and it's multiplication. So we can ask ourselves, well, what two numbers next to each other, or consecutive numbers, are equal to 42? Well, 6 times 7 is 42. So now be very, very careful. Even if you look at how I wrote this, was not the best way. I want to go in descending order. So I'll go 7 times 6, which means my n is actually equal to 7. Okay, so that wasn't so bad, but let's take a look at this next one where we've got this expression. So we want to express it as factorials and simplify as much as possible. This is going to end up being a complex fraction because of how my combination formula is. So the first thing I would do is let's just rewrite this as a normal division. So n minus 1, choose 3. Now I'm going to use my combination formula, so it's going to become n factorial all over 5 factorial, and then n minus 5 factorial divided by n minus 1 factorial divided by 3 factorial. It's maybe a little bit tricky. You still have the n minus 1, but then you're also subtracting 3, and that's going to become factorial. Next, I want to turn this into a multiplication. So I'm going to reciprocate the second fraction just to see if there's anything I can simplify maybe across. I know it might be tempting to say, hey, look, this n factorial and n minus 5 factorial, I could do some simplification there. You might be making your life a little bit harder though. So let's just see if there's anything we can simplify across these fractions. So I'm going to leave the first fraction the same, turn this into a multiplication, and then reciprocate the second fraction. So that's n minus 4 factorial all over n minus 1 factorial. So now it's maybe a little more obvious that n factorial and n minus 1 factorial, well, they're only like really one term apart from each other. And same with n minus 4 and n minus 5. They're very, very close, which would be a much better simplification than maybe doing just the n factorial and n minus 5 factorial. So I'm going to change these forms just so that they kind of match across. So this n factorial over 5 factorial. So this n minus 5 is going to stay the same. And sorry, I got to change this numerator actually so that it becomes n minus 1 factorial. There we go. And then 3 factorial. And here we're going to have n minus 4, and then we'll subtract 1 to make it n minus 5 factorial all over n minus 1 factorial. So that actually simplifies quite a bit because now we have n minus 5 factorial cancels out n minus 5 factorial. N minus 1 factorial cancels out with n minus 1 factorial. So that step right there is huge. All of a sudden we have, well, 3 factorial becomes 6. And we have the n. And don't forget about the n minus 4 that's left there as well. Okay, so then my denominator, well, 5 factorial is 120. And 6 divided by 120, so we can simplify that a little bit, and it becomes n times n minus 4 all over 20. It's in factored form. It doesn't specify which way, so we're going to leave it in factored form. I want to take a look at one last equation like this where we're solving for n. So we have 2 times n choose 2 is equal to n plus 1 choose 3. So I'm going to use my combination formula right away. So it's going to be 2 times and then n factorial divided by 2 factorial and then n minus 2 factorial. And that's equal to n plus 1 factorial all over 3 factorial. And then here we have n plus 1 minus 3 factorial. So this looks a lot worse than it is, but as soon as you start doing some simplifications, it's okay. 2 factorial is actually 2, so the opposite of dividing by 2 is multiplying by 2. That gets rid of that right away. It might be tempting to do some cancellation between the n factorial and n minus 2 factorial. However, if you just patience for a second, you'll see that this denominator is n minus 2 factorial, and actually on the right side, it's going to be the same thing, at least for the n part. So we still have 3 factorial, which is 6, but we actually get n minus 2 factorial when we simplify 1 minus 3, which means I can multiply both sides by n minus 2 factorial and get rid of that part. So now we have n factorial is equal to n plus 1 factorial all over 6. Next, I'm going to multiply both sides by 6, so I get 6n factorial is equal to n plus 1 factorial. Some of you might know right away that this is just going to swap places, because now I'm going to divide both sides by n factorial. I'm trying to get those n variable all on one side. So we get n plus 1 factorial over n factorial. And now I should be able to simplify this factorial if I make the factorials the same. So I get n plus 1 and then times n factorial all over n factorial. So we'll do it. That division is equal to 1. So all we're left with then is 6 is equal to n plus 1. Subtract 1 on each side, so we get n is equal to 5.